Let me dive into a little bit about myself. So my name is Fluin, and I am head of developer relations at a company called Chainlink Labs. So at Chainlink Labs, we work on the Chainlink network and technology stack. So you can reach out to me on email or Twitter if you have any questions around this, and we'll be doing a Q&A at the end of the talk. So today what we're going to be covering is, we'll break things down into three sections. First, I want to talk a little bit about cryptographic truth and why truth matters and ways that we can empower you with that truth. Then I'm going to go into talking a little bit about data, how to access it, and how to enrich your applications with data. And finally, I want to connect your smart contracts to the world, talking a little bit about how to access any arbitrary endpoint that you might be looking to connect with. To start off with cryptographic truth, I want to give a little bit of background in terms of how we think about this situation. So a long time ago, we had paper-based agreements, right? Everyone would sign on the dotted line, and we've moved a little bit now in 2021 to, I think probably most of the things that I sign personally are digital agreements, right? With my bank, with an investment company, with a contractor, all those sorts of things. I end up signing a lot of things online. But from many perspectives, the digital agreements that we have today are the same thing that we had on paper, right? These are very trust-based contracts. And really, you're relying on all the participants to uphold their side of the contract, no matter what's happening, no matter what situation's going on in the world. And that means that these agreements have a lot of trust, and we think that there might be a better way. And so we talk about this idea of cryptographic truth as really the answer to that, where we believe cryptographic truth is strictly better than this idea of just trusting us. And you can kind of think of this as a spectrum, where on one end of the spectrum, you've got this trust us, paper promises, like we see this a lot with Ponzi schemes. This is actually the same sort of thing that happens with insurance banks, fiat currency. And then on the other end of the spectrum, you've got this idea of cryptographic truth, which is multi-signature, powered by hybrid smart contracts, powered by blockchain, where instead of relying on these digital agreements that trust each individual to behave, we're actually relying on programs and applications and systems that enforce correct behavior. So the way that we get here is via smart contracts. And so I like to think of smart contracts as superior digital agreements, where instead of being purely based on trust, they have a bunch of different attributes that are very, very helpful. First among them is security. When you write a smart contract, it is tamper-proof, right? These things are immutable. When you put it on the blockchain, it is going to be there as it is forever. And so it can't be influenced by a single party. Smart contracts on the blockchain are also guaranteed execution. So instead of waiting for someone to actually fulfill their part of the bargain or contract, that your agreement that you've made, you're actually relying on the entire system to actually do the execution. So it's performed by an always-on decentralized network rather than relying on an individual. There's a huge amount of transparency. These smart contract-based agreements actually ensure that whatever's happening on the blockchain is visible to everyone, and you actually know what's going on at all times. There's also this concept of trust minimization. So you don't have to rely on either party to behave in a specific way, right? The parties that are creating the agreement are not involved in how the agreement executes or enforcing that it makes sure it does. And lastly, all these properties give you a level of efficiency where these traits come together and combine to allow you to migrate existing kind of more manual processes into an automated system where you automatically get the result that you're hoping for rather than waiting for someone to go and execute that part of the agreement. Cryptographic truth is strictly better than this just trust us for a few other ways too. Control is completely given away in just trust us paper-based agreements, right? It is not you that is in charge, you're relying on someone else. And the counterparty risk is high, and oftentimes it's opaque. You don't know necessarily what's going on and what the other party wants and how they're going to operate. And transparency is sometimes purposefully removed. Where if you contrast that with the cryptographic truth side of this, the control is always in the user's hands. You know what's going to be going on. The risk is low and transparency is unavoidable. It's built into the way that we build these platforms and the way that we write dApps. And so one of the things that this creates is a really, really exciting place to build applications, but it has a little bit of a problem, which is that smart contracts in and of themselves have all these really nice properties, right? They're based on cryptographic truth and consensus systems, but they're not actually able to connect to external systems, APIs, payment systems, any other off-chain resources are not available when you write a smart contract, right? Your smart contract can only access the things that exist on the blockchain. And we call this the Oracle problem for one main reason, which is that in a consensus-based system like the blockchain, everything that's deterministic is very, very easy, right? 1 plus 1 is always going to be 2. All the nodes are going to have the same calculation, end up with the same result, and agree on it. But that's not actually true for some types of things. So there's a lot of non-deterministic type processes. So an example of that is if you're looking for randomness, right? And you ask 1,000 nodes to give you a random number, they're not all going to create a random number in the same way. And so they can't really coordinate and build a consensus on that. There's also API calls, right? If you need to access something from the external world, how can you trust that the result that you're going to get back from that API is going to be the same or truthful from all of the different nodes that are making those API calls? And so this really creates a smart contract connectivity problem where we've got all these really great data sets out there from market data, events data, payments, bank systems. There's so much data in the world that empowers and builds the software world that we rely on every day that aren't available on blockchains natively. And there is a solution to this problem, and that is the blockchain oracle. Right? We define an oracle as any device that interacts with the off-chain world to provide external data or computation to smart contracts. But you might think, oh, I can go build an oracle. That's easy. I'm just going to go build a piece of software, and we'll create a node, and that node will be responsible for pulling in any data that I need, and it'll just put it on the blockchain for me. And this is the approach that a lot of people take. This is kind of the naive default approach. But that central oracle is actually a point of failure. If that node fails, now you don't have the data you need. And almost more importantly, if that central node is manipulated in any way, it has a huge amount of control and power. So let's imagine you were pricing some sort of asset and you only had a single oracle node coming up with that price. There'd be a huge financial incentive for the person that controls that node to fluctuate the price. And that would create disincentives that creates all sorts of problems that would make you less effective in using that oracle. And so our solution to that problem is a decentralized oracle network using Chainlink. So what you can have with a decentralized oracle network is you can have a bunch of different nodes working together, being run independently to develop a consensus about some sort of data or computation that then enriches your smart contract in a way that you don't have to rely on trust. You can look at the truth of the aggregate consensus. So each node can be doing data validation and checking all of the individual chains, coming up with different data sources, all these sorts of things. And it comes up with a better system as an aggregate and as a result. If you look at the Chainlink decentralized oracle networks, you're going to find node operators that have been security reviewed and have a history of performance. So what actually happens? So let's imagine that you want to get a price on chain. And so what we do is you have a whole bunch of nodes that are pulling from a whole bunch of different data sources across the board. So they might actually disagree on what a specific price is at a given moment. But the magic of the network here is that they are actually going to work together to come up with a consensus that delivers a result that is the best result at the time. And so what you've done by taking advantage of real-world off-chain data and computation is you've now built a hybrid smart contract. So these are smart contracts just like you know and love, but now you're actually able to build new types of applications and solve new problems using that data and using that computation. One thing to know about Chainlink is that we are on Fantom, but we're also blockchain agnostic. So our node software operates with basically any chain that you might be working on. And so we really do see this idea of let's live in a multi-chain world, let's live in a many-chain world, but then also be where developers are and allow you to use the chains that you want to be using. Next up, I want to talk about how we can use this idea of a decentralized oracle network to interact with and get data into our application. So you may have heard of this thing called DeFi or decentralized finance. It's super popular now and it's actually becoming a really big deal because DeFi allows you to take advantage of this cryptographic truth guarantee in order to do standard financial operations such as investing, such as trading, those sorts of things. And so you can actually access decentralized finance in a way that sometimes the global financial markets won't let you. There's a huge number of companies that are championing and pioneering the future of DeFi, but I want to name a few that are actually already relying on Chainlink's decentralized oracle networks. So you've got Synthetics, which is synthetic assets that you can actually invest in with over 2 billion secured. You've got decentralized exchanges like SushiSwap. You've got Set Protocol, and you've got lending and borrowing platforms like Aave. So these are all fantastic systems that are at scale using Chainlink in order to use cryptographic truth to determine the functionality and the behavior of their applications. we actually, if you look at the data, Chainlink decentralized feeds actually secure most of DeFi. So if you look across, Chainlink's decentralized data has actually become very, very popular and is used by a huge percent of the market overall. And this is actually a big deal because oracles and the data that you pull on chain is a big deal. It affects people's livelihoods. It affects a lot of money. It affects a lot of the way that we build and secure our applications. There's been notable security attacks against oracles that if you're not using a decentralized network or you're not using a good decentralized network, you can end up having problems. One of the best ways to understand what you can do with Chainlink is to check out data.chain.link. And I actually want to do this right now. So I'm going to jump over into a tab here and we're going to take a look at the data.chain.link website. And I've already clicked on Fantom, so you can see the price feeds that we have here. And for each of these price feeds, you can actually click in, you can see all of the nodes that are powering the network. And then because all of this has full transparency, you can actually look at the price history that we've shown, as well as all of the individual results from all of those node operators. So you can see when they submitted into the chain, what the data was, and you can look at all the details because all of this information is fully transparent and available on chain. So if you think about Chainlink data feeds, you should realize that these data feeds have full market coverage, both from decentralized exchanges as well as from centralized exchanges, right? They're looking at the entire market to determine things like prices. You're going to find a mix of both premium providers, aggregators, as well as pulling in some of the data from exchanges. The system uses volume-based average method for aggregating the data. And we've got feeds live on many, many blockchains, and we have more launching almost every single day. And a lot of our feeds are now using something called OCR, which is actually a really interesting concept. So OCR stands for off-chain reporting. So one of the problems when you build an Oracle network is it's a lot of coordination between a lot of different nodes. And so we've come up with a really great solution. So OCR basically has each node reporting their result over a peer-to-peer network, and that result is signed by that node. And then what ends up happening is one single node ends up submitting that on-chain. And so all of the data from all of the nodes is available to everyone, and the aggregation is still done on-chain, so you can still know that it's being cryptographically proven. But this technique actually reduces gas costs by up to 90%, which is a huge deal depending on the networks and the amount of transactions you're pushing through. So I actually want to do a data feed demo here real quick. So let me walk you through what we're about to demo. So first we're going to leverage the Chainlink tutorial. And then we're going to go ahead and we're going to deploy a smart contract. We're going to build a smart contract using some sample code. And then what we'll do is we'll actually have a view into the target data feed. So for this case, we'll just look at FTM USD as the data feed that we're going to be building. So let's go ahead and give this a try. So the place I'm going to start is I'm going to go to docs.chain.link. So this is our documentation site. We put a lot of time and effort into here. And I'm just going to go to the basics tutorial. So the basics tutorial is the one that covers how do you consume data. And it also has a lot of additional information. If you've never written a smart contract before, this is actually a great place to start. Figure out how to get a wallet, how to get set up, how to understand what smart contracts are, understand Solidity, all those sorts of things. But what I'm going to do is I'm going to scroll down here to this code example. And so this is a code example of how we pull data in from a data feed. And what I'll do is I'll just click this nice button here. It says deploy this contract using Remix. Remix is a web-based IDE for writing smart contracts. And just like that, we now actually have a contract here that we can start writing and we can start reading. So let me walk you through just very briefly what this contract is doing. So this is written in a language called Solidity, and we have an import here. So we're importing an interface so that our contract knows how to interact with a other contract on the blockchain. We've got a constructor that sets up this smart contract and connects it to a data feed using this thing called an aggregator v3 interface. And then we have a single view method here that allows you to, without a transaction, actually view what the latest price is of the pair that we've selected. And so in order to actually use the smart contract, I just need to swap out the address that I want to interact with. And so what I'm going to do is I'm going to use that docs site again. So docs.chain.link. I'm going to go down here and I'm going to click on Fantom data feeds. And I will just pick out the data feed I want from a testnet. So we'll just copy that and we'll paste that directly into our contract. So now we've actually written all the code that we need to write to deploy a smart contract that uses that data on chain. So let's go ahead over to the compiler, make sure that this compiles, and we should be good there. And now we'll head over to deploy. And now instead of using the VM, I'm going to actually use the injected Web3 provider and connect it to the Fantom testnet. So from here, I can select the right contract, and I'm going to hit the deploy button. So the deploy button is going to trigger MetaMask to ask me to pay for this transaction on the Fantom testnet. And we'll see that that transaction is pending here. And as soon as that goes through, I will get back an address and our contract is deployed. So we can see now that our contract is deployed, and now we can actually invoke this view method. And so I'll just call get latest price, and we will see here is the latest price for FTM USD. So we did it. That was pretty easy. Live coding is a little bit hard. Sometimes I feel like I'm back being a child again, but we were very successful here. So we did it. Complete success. So we talked about how do you access data from on-chain using these aggregators, using these existing data feeds, but the things that you can do with Chainlink are so much more, right? You can actually access any API that exists out there. And we know that most of the web is actually powered by APIs. And so this can be a very, very powerful way to access capabilities and data within the blockchain, within your smart contract application. And so you can think about this as having two ends, right? You've got any input backend and any output. So there's fantastic examples from across the blockchain ecosystem, from interacting with and reading and controlling your IoT devices to just interacting with corporate and enterprise devices and software, to anything that you can come up with. You can use Chainlink Decentralized Oracle networks, or you can even spin up your own Chainlink nodes in order to power this. So when you want to spin up your own Chainlink node, one of the things you're going to want to know about is about adapters. So adapters are effectively this piece of software that has an input and an output and allows you to basically do anything at the Oracle layer. So most of the time we've got a lot of adapters that are for hitting backends, pulling in binary data, pulling in numbers, all those sorts of things. But effectively, there's a structured input and output JSON specification for every adapter. So you've got these standardized APIs that let you connect to and really do anything via the Chainlink node. There's a fantastic website you should check out called the Chainlink Market, maintained by the community. You can find it at market.link. And what they've done is they've actually started mapping all of the jobs, adapters, feeds, data providers, etc., from across the ecosystem so that you can find things that you can access right now. So this includes a lot of the feeds that are listed on the doc site, but then also some other feeds that aren't, as well as a lot of independent node operators. So to really illustrate this, I like to think about the old concept of trading cards, right? I remember growing up, a lot of people had like baseball trading cards. And you can imagine very easily how a trading card could end up being an NFT. But with a decentralized Oracle network like Chainlink, you can actually do so much more. And so you can use any API to access, for example, sports data about some of your favorite players. And this would allow you to build an NFT that is not just static, but it's actually a dynamic NFT, where the NFT evolves and changes and grows and adapts based on what's happening in the real world. So imagine an NFT of your favorite player, where as they achieve certain accomplishments, getting Rookie of the Year, getting named MVP, or whatever that is, they actually have their NFT grow and change to reflect that. That would make your NFT so much more valuable, so much more interesting, so much better at reflecting and acknowledging and being useful for someone as they have it in the real world. So there's a whole bunch of other capabilities. Everything I've talked about so far is available on Fantom today, but there's other capabilities that are coming to Fantom at some point in the future. So one of the things that is really, really big for a lot of developers is this idea of randomness. I touched on this before, how this is actually a hard problem, not only from how do you come up with a consensus version of a random number, but also how do you do it in a way that miners can't manipulate it, or the transaction order doesn't negatively affect that, those sorts of things. And so Chainlink actually has a solution to that called our verifiably random function, or VRF. We also have a solution for automation and off-chain computation using Chainlink keepers. I personally absolutely love Chainlink keepers because effectively what you can do is you can write a smart contract that has a check method that figures out when the smart contract should be running and when it should actually do something, and then it has a perform method. And the magic part here is that the check method actually runs off-chain, and so you can do that very, very cheaply without any gas costs. But then as soon as something needs to happen, you can pass data from that check function into some sort of function that's being performed on-chain, save a bunch of gas, make sure that things are happening at the right time in the right way, and then verify everything on-chain. So I'd highly recommend that everyone watching this, if you haven't used Chainlink, if you haven't tried spinning up one of our starter kits or gone to our docs page and followed one of our tutorials, definitely give it a try, because from data feeds to any API, there's a lot of things that you can do today with Fantom to really enrich your smart contracts and turn them into hybrid smart contracts. So we talked about data feeds and any API. If you want to get started, I definitely recommend you start at docs.chain.link. We've got fantastic links out to all these tutorials that I've mentioned today, as well as lots more. The other thing that you could consider doing is last week we kicked off the Chainlink Fall Hackathon. So this started on October 22nd, where now we actually have an opportunity for smart contract developers, new and experienced, to come in, build something. A couple of things are new this year. First, we actually wanted more people to feel like winners, and so we dramatically bumped up the number of prizes. So there's more opportunities than ever for you to become a smart contract developer, be successful. We saw that about a third of the people that participated in our last hackathon were new to smart contract development or hadn't written Solidity before. So it is never too late to get started and give things a try. The other thing that I want to mention that we're doing new with this hackathon is participating in a hackathon like this is actually a big career boost. You can take your projects further and you can get more eyes on them. And so to kind of underscore that and reflect that, we're actually doing a VC pitch day with all of the winners. So we're giving all the winners an opportunity to connect with a bunch of VCs and actually pitch their idea and say, hey, how can we accelerate this? How can we take these projects to the next level? So we're also hiring. So if you're interested in this idea of helping build a world powered by truth, definitely think about joining us. We build a great open source project that powers DeFi and a lot of the rest of the world of the blockchain industry. We're an idea meritocracy, so the best ideas win here. So if you've got great ideas, we'd love to hear them. And we're a remote team working with great people all over the world. So that is going to be it for me. I think we have a bit of a Q&A now, but thank you so much for coming and thank you so much for listening.